Hey guys, welcome back to the laboratory. In this video, we are looking at how mixtures are separated using chromatography. By the end of this video, you should be able to describe how chromatography is used to separate mixtures and identify when chromatography is used as a separation technique. So, let's go. Chromatography is a separation technique used to separate a mixture of soluble substances. That is, a mixture of dissolved substances. Take the different dyes in ink as an example. To carry out this technique, you'll need a special piece of paper called chromatography paper. A pencil line is drawn near the bottom of the paper, and dots of each substance you wish to separate are added to the line and labelled. There's a couple of things to note here. Firstly, it's important that a pencil is used when drawing the line on the chromatography paper. This is because pencil is insoluble and will not interfere with the results of your experiment. And secondly, it's important that the dots of each substance are well spaced on the pencil line, as you do not want them to run into each other during the process. Next, the chromatography paper is added to a solvent. The solvent commonly used here is water. The water will begin to move up the paper via capillary action, and as it moves, it will dissolve the different substances and carry them up the paper too. The solvent is the mobile phase here as it moves, and the chromatography paper is the stationary phase as it does not move. Once the solvent has reached the top of the paper is removed from the beaker and analysed. On this particular chromatogram, substances A and B have both separated into one spot. When a substance separates into one spot, this means it contains only one substance, and so it is a pure substance. In contrast, substance C has separated into two spots. When a substance separates into two or more spots, this means it contains two or more substances, and so it is a mixture. Substance D, however, has not moved from the pencil line, and this can mean one of two things. 1. The substance is insoluble, or 2. The substance does not dissolve in the solvent used. If the second reason is true, then the experiment is to be conducted again with a different solvent. Substances B and C both contain the same dye. Notice here that they both contain a blue spot that has moved the exact same distance on the chromatogram. And finally, the distance moved by a spot relates directly to its solubility. The most soluble substances are found towards the top of the chromatogram, and the least soluble are towards the bottom. On this particular chromatogram, the red spot in substance A is the most soluble, and the yellow spot in substance C is the least soluble. In chromatography, calculating the RF value of a substance is extremely useful when identifying unknown compounds, as each substance has its own unique RF value. The RF value of a substance is simply a ratio of the distance moved by the solute compared with the distance moved by the solvent. And to calculate the RF value, you would need to measure the distance moved by the solute and divide it by the distance moved by the solvent. For example, on this chromatogram, the distance moved by the solvent is 4 centimeters. The distance moved by the red spot is 1 centimeter, and the distance moved by the yellow spot is 2 centimeters. To calculate the RF value of the red spot, you would divide 1 by 4. The RF value of the red spot is 0.25. To calculate the RF value of the yellow spot, you would divide 2 by 4. The RF value of the yellow spot is 0.5. Here's an example of an exam-style question that you may be asked on this topic. Pause the video, read the question, and take your time to answer. I'll be waiting for you on the other end with the mark scheme. This first question is quite straightforward. You are being asked to calculate the RF value of the dye found in inks X and Z. These two spots are in the exact same place in inks X and Z, and so we are calculating the RF value for this spot. Using the ruler provided, the distance travelled by the spot is 3.9 centimeters. The distance travelled by the solvent is provided in the question, and so all that is left to do is to substitute our formula. The formula for this question is 3.9 divided by 6.5, which is equal to 0.6. The RF value of this spot is 0.6. The question continues and indicates that sample Y did not move from the pencil line. What change can be made to get the ink to separate? There is only one way to go about this, and this is by changing the solvent. To achieve the 2 marks here, you would have needed to mention that the solvent should be changed so that the ink will dissolve. So, how did you do? Let me know in the comments below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!